Today we're having a brief presentation by David Martin at Argonne National Lab. So we'll turn it over to Argonne.
So I always like to show this. This is the strategic priorities at Argonne. Argonne is a national laboratory funded primarily by the Department of Energy, and these are the five kind of focus areas. And my favorite one is the second one there, just to show that advanced computing is one of our core competencies and focuses. But the others to notice is all of the others there require high performance computing, and we're tied into all of those efforts as well. So you can't do the material and chemistry or manufacturing or some of the universes or laboratory work without doing advanced computing. So here's the 5 user facilities that are Argonne. I'll kind of skip over that, but I wanted to kind of point out that the way DOE treats these big computing centers is similar to a scientific instrument. So they treat us in funding and in the way we're organized very much like a photon source or a linear accelerator. So these are a set of rules that all of the user facilities with the DOE complex use. And so the way that you get access is open to everybody. So there's no restrictions on the funding organization, the funding source, the nationality, the research area. The idea of the leadership computing facilities, and indeed all of the user facilities throughout the DOE complex, is to do the best science available and to get the best researchers in the world to do it on these facilities. There's no charge to do open science work. There is a way to do proprietary work with cost recovery. And if you have questions about exactly how that works, you know, I'll be glad to speak offline with people, but just know there are ways to get proprietary access as well. The way you get access on almost any of the user facilities and almost any of the allocation programs is through a peer-reviewed system. And so it's very much like submitting a research paper or a funding grant, except the thing you get back is computing time and expert help, not necessarily cash. The LCFs don't provide actual funding directly to people. We just work in collaboration and provide the resources. And then the last thing that all the user facilities provide is expert support. And so we have computational scientists on staff that help people do this. So, you know, in addition to the current computing and the expert support, we're always working on next generation machines and software, and I'll talk about that a little bit. This is a couple of our allocation programs that I'll get into and the breakdown. So you can see it's a pretty broad selection of scientific communities that are using it. A lot around material science and physics, as you'd expect, but we do a good bit of earth sciences work around climate modeling, a lot of computer science work. So it's really not restricted to anybody who wants to use these systems. So these are 2 big systems right now, are Mira and Theta. Mira is an IBM Blue Gene Q system. Theta is an Intel system built by Cray using the Intel Knights Landing or Xeon Phi processors. Both of these run at about 10 petaflops, and both of them are highly parallel and homogeneous systems. And so they don't use accelerators. They're all using the homogeneous CPU cores throughout the system. Theta has kind of the larger storage system by doing around 30 petabytes or so of storage. But there's a fairly significant file system on Theta as well. We have ways of moving stuff back and forth. We also at Argonne have a wide selection of other computing environments, and so you don't necessarily have to start out at a leadership class machine to try things out. And so we've got division clusters, we've got something from a transportation research center, and then LCRC, which runs the BBOT cluster here. So, you know, the thing that, it's kind of interesting, I give tours fairly often of LCF Resources and people ask to see Aurora. Well, Aurora will arrive in 2021, but we're already very heavily working on the planning for it, the software, the hardware, the training, and everything. Aurora was originally a 2018 machine, and when the drive for exascale heated up, we moved it to be delivered in 2021, and so you can see a little timeline there. It's expected to kind of show up in, you know, kind of late next year. There are some pieces showing up, and then in 2021 should be some availability. Here's, you know, it's still fairly proprietary, but here's what we're allowed to say publicly about what Aurora will look like. We will be using the Deos distributed object store that Intel has developed with about a 230 petabyte file system as our plan. It's going to use a combination of standard Intel, which switched over there, Intel Xeon processors with Intel GPU-based systems. And so they'll be kind of the bifurcation. It's our first system that has accelerators. And so we're excited about figuring out how to program that. It'll use the Shasta Slingshot interconnect, and then there's something called Intel One API, which is an effort for Intel to kind of, across their whole product line, come up with a way to do highly parallel programming. And I stole this picture from Catherine Raleigh, our Director of Science at ALCF, about the interrelation between simulation and data analysis and machine learning, and then a little bit of visualization too down at the bottom. So it's really intended to be a system that does all of these well and has the capability to integrate simulation and data analysis and machine learning. So people ask about how you get access to these. There are two big allocation programs, Insight and ALCC. Insight is run jointly with Oak Ridge National Laboratory. They have OLCF there. And once a year, we open up the whole proposal process. It's very extensive. It includes both a computational readiness review and a scientific peer review. So that's a good chunk of the time we give out, but DOE directly gives out something through the Oscar Leadership Computing Challenge. And so that time is given out by DOE directly, and then we have director discretionary time. So there are other ways, though, to engage with ALCF. I mentioned Insight and ALCC in the director's program, but there is an ALCF data science program that gives time and expert help as well. There's an early science program to allow people access to simulators and advanced knowledge about the Aurora system. Those projects have already been chosen, but those projects are also open to collaboration. The Exascale Computing Project is this huge effort across many of the DOE labs to prepare the software and infrastructure needed for Exascale. And they have some time allocated, and so you can work with them. And then I wanted to just highlight the HPC for Energy Innovations program, and it has 3 pillars in manufacturing, materials, and mobility. And that has some time allocated and also provides some funding to the Department of Energy labs to work with industry directly. And then there's lots of stuff around proprietary agreements there that I won't get into. We also rely on a lot of the expertise at Argonne, and I won't hit all these in great detail, but I really wanted to point out that we have new computational science and data science and learning divisions that we draw on to help people understand how to use these big systems. So I'll end with a picture of our ALCS staff, because the real way of doing collaboration with this is talking to our staff. And so getting connected to people on a personal level is probably the best way to start collaborating with ALCF. So, you can talk to me or Marta or any of the people who at ALCF, and we can help make the connections. All right, so I think I've almost finished my time. I probably have like 1 minute for questions. Marta, do we have any that have come in over Slack?
We'll ask people to go ahead and post questions for David through the Slack channel. Thank you very much, David. Appreciate it.
Thanks.